Okay, in this video I want to just spend a little bit of time talking about distance time graphs because some people have difficulties with them. So and then we'll also talk about velocity time graphs. So suppose this is distance and this is time. Now, time we know what positive time is. In terms of distance, we could say up and down, forward, back, left, right. I think I'm going to say this is forward, and this is going to be backwards. And so we've got a graph that looks like this. Okay. And let's put some numbers on here. 1, 2, 1, 2, -1, -2. And we're going to mark some points. We're going to call this point A, point B, point C, point D, point E, point F, point G. Okay, so now we want to think about what's happening at each of these points. Well, at point A, the object is moving forward. So, object is moving forward. So it's got positive velocity. Okay, at B, object is stopped at some forward location. And we'll call that plus 2 meters. Plus 2 meters. The object is stopped at some forward location. C is moving backwards. Towards its original starting point. Now at D, it is still moving backwards, and passing through original starting point. So at D, it's still moving backwards, but it's passing through its original starting point. E, it is stopped at -1 meter. F, moving forward through original starting point. And then at G, it is stopped at +1 meter. Okay. That's a distance and time. So slope in a distance time graph, the slope equals velocity. Okay, now we're going to talk about a velocity time graph. Okay, and we're going to make it almost the exact same thing. Velocity, and this is going to be forward, backward. This is going to be time, and almost the exact same thing. A, B, C, D, E, F, G. Okay, but they're going to have different meanings. Okay, A, object is moving forward and accelerating forward. This is key. The object is moving forward and accelerating forward. I'm going to flip this around. Slope on this graph is acceleration. Now, what's happening at B? It is moving forward with no acceleration. At C, it is still moving forward, but accelerating backward, which means it is slowing down. It is still moving forward because its velocity is still forward, but the velocity is getting less and less forward, so it is slowing down. Now, at D, it is stopped. But accelerating backwards. The key thing is, on a distance time graph, when it crosses back through the axis, that's where it's stopped. Okay, two more real quick, or three more real quick. At E, it is moving backwards with maximum negative velocity. This is the place where it's moving back as fast as possible. This is the place where it's moving forward as much as possible. At F, it is stopped, but accelerating forward. And at G, it is moving forward without acceleration. Okay, that's that.